For my technical presentation for CIT335, I will be discussing additive manufacturing, better known as 3D printing. This process is rapidly growing on both the personal and commercial levels. But how does it work? How has technology gotten to where it is now? What types of products are out there? Can I get one? Who would use this operation type and what would they use it for? What does the future hold for additive manufacturing? All of these questions and more will be answered today. There are several specific and sometimes proprietary ways additive manufacturing has been created and utilized. On a basic level, additive manufacturing is exactly what the name says. You add material rather than the traditional ways of manufacturing items or products, which was removing material. With this type of process, there is much less material waste, and in some cases, no waste at all. The spectrum of materials we are able to use when 3D printing is very large and growing as new materials are being created. Another major positive to 3D printing is the upgrades and add-ons for physical machines can typically be created on the machine. To create a product, you would draw the product as a 3D model in a CAD or computer-aided design program, or download the desired model from the internet. You then would use a slicer software to turn the 3D model into many layers. The layers are what a 3D printer creates, so as the layers get produced, by adding material on the previous layer, the piece gets larger and closer to the final product. When this technology was first discovered, it was referred to as rapid prototyping. The first patent application for this process was filed in 1980, but was not completed by the deadline, so it was still free game. A patent application was later filed and completed in 1986 for an SLA machine that was invented in 1983 by co-founder of 3D Systems Corporation. The SLA-1 was the first commercial rapid prototyping machine, which was created in 1987 and sold in 1988 by the 3D Systems Corporation. In 1989, a company named DTM Inc. acquired a patent for the SLS style rapid prototyping machine. Also in 1989, the FDM machine was patented by the co-founder of Statsi. In 1990, EOS sold their first direct metal laser sintering machine that they called Stereo. Throughout these early years, there were many other patents issued for the process, such as ballistic particle manufacturing, laminated object manufacturing, solid ground curing, and three-dimensional printing. Many companies were emerging through the 90s, and in 2000 the SLM technology was introduced. In 2007, 3D Systems introduced the first system under $10,000, but was still far too expensive for the hobbyist looking for the desktop version. In 2009, the kit form of the 3D printers was put on the market and made it easy and inexpensive for regular Joes. Around this time, RepRap emerged. This is an online community with an open source outlook. This keeps the technology at low cost and available and deters commercialization. There are many different types of additive manufacturing machines that operate in many different ways. The stereolithography SL or SLA machine uses a pool of photopolymer with the work table submerged. A laser shoots a beam in the programmed area, causing the polymer to harden, creating a layer of the finished product. Once the layer is finished, the table moves up and the next layer is made until the part is complete. Digital light processing, or DLP, is similar to SLA, but it uses a different light source to cure the polymer. DLP has a shallower tank for the polymer, therefore it has a lower running cost. Laser sintering, or laser melting machines, use lasers and powdered material. The powdered material is rolled tightly on the workbed, and the laser traces the shape of the part one layer at a time. Laser sintering machines can use much harder materials than SLA and DLP machines, but they are much less precise. Extrusion style 3D printers are the most common kind. They are typically referred to as fusion deposition modeling, or FDM, or freeform fabrication, or FFF. This method uses the extrusion method with plastic filament. The filament is heated up and forced through an extruder, creating a layer at a time. The bed lowers as the layer is completed. The next layer is extruded on the top of it. There are also two types of jetting processes for 3D printing. Binder jetting 3D printers that expel a binder into a bed of powdered material, and material jetting 3D printing. that shoots out the material that is immediately cured by UV light. Select disposition lamination, or SDL, is a proprietary technology but is assumed to be similar to laminated object manufacturing, or LOM, in that they both use printer paper to create the final product. SDL printers can create items with many different colors in it. This process uses paper that has each layer printed on it, then is cut and tightly glued together to form the final product. The electron beam melting technique is also proprietary. It is similar to laser sintering, but rather than a laser process, it uses an electron beam. There are many different applications that find additive manufacturing very useful. Rapid prototyping is the most common reason for 3D printing right now. 3D printing is used in a broad range of industries. A lot of companies use these machines to make custom, one-of-a-kind pieces of jewelry. Clothing designers also use 3D printers to model their ideas. The medical and dental industries have harnessed this technology to create different implants and prosthetics. Almost all hearing aids are made through 3D printing. Many parts of CPAP machines are also made with 3D printing. And the mold of your teeth when you get Invisalign aligners is 3D printed. The aerospace industry is using additive manufacturing to make highly complicated airplane and engine components from very strong materials. Automotive manufacturers and architects use this technique to prototype their ideas. The use of 3D printers to create edible masterpieces is also on the rise. This process can also cut major costs of making molds or even eliminate injection molding procedures altogether. Wax castings have become very popular in the 3D printing world as well. Although 3D printing is a great technology, it is not perfect. Even though you can get a starter kit system for less than $200 at Walmart, I know this because I ordered one last week, the high-end machines can go well above $1 million. After creating the parts, there is often finish work that is required to acquire the desired finish and size. This is typically done with conventional machining. Depending on the design of the parts, they may need support structures that will be removed after the part is completed. This can also require conventional machining to finish. Another downside of this process is gases. Oftentimes, the gases and fumes given off during production are poisonous. Ventilation and seclusion are two important factors when determining where your machine will be located. The material powder can not only be toxic, but in most cases it is very flammable. Depending on the machine and its capabilities, the use of many materials may require extreme upgrades to the system, and it's sometimes not even possible to use certain materials. Although this may be a quick way to make a prototype, it is not necessarily the fastest way to produce parts. It could take hours, days, or even weeks to produce some parts depending on their complexities. It is very time-consuming when it is time to change the material in an industrial atmosphere. Workers wear hazmat suits with respirators, and they must make sure every little speck of old material is out before putting the new material in. Although 3D printing can turn 300-piece assemblies into 10-piece assemblies with its ability to make complex shapes and designs, which would save tons of money and time. If a component fails on a part like this, it will have to be remade rather than just repairing a piece of the assembly. What might the future hold for 3D printing? The options are limitless. Studies are being done to try and create living tissue. This could mean kidneys and other organs being artificially produced with a 3D printer, then put directly into a person's body. Also think about when your car needs parts, but the auto parts store does not have them in stock or they are closed. It's possible to see these items being sent to a home 3D printer and made in a few short hours instead of waiting weeks for delivery. There are trials being held to produce vitamin-rich meals via additive manufacturing as well. There are advantages and disadvantages to processing with 3D printing. Some like it, some don't. Whether you choose to embrace this technology or let it pass you by, make no mistake, this is our future and it's right around the corner.